CXC January 2018. Solution to paper 2. This is question 10. The diagram below, not drawn to scale, shows a circle with center O. So here is the center of the circle. The points A, B, C, and D are on the circumference of the circle. So these points are on the circumference of the circle, and we know that it is having 4 sides, so it's a quadrilateral, and a quadrilateral that touches a quadrilateral whose 4 sides touches the circle is called cyclic quadrilateral. So you're going to apply the properties of a cyclic quadrilateral to solve the question, and also EAF, and EDG are tangents to the circle at A and D respectively. So we apply the properties of tangents to a circle also. Then angle AOD is equal to 114 degrees and CDG is equal to 18 degrees. Now the first question, you're supposed to calculate, giving reasons for each step of your answer, the measure of angle ACD, angle ACD. So that is the first on the list over here. Now we know angle ACD is equal to half of angle AOD, angle AOD. The reason is that the angles are tended at the circumference. So angle created at the center, angle created at the circumference at the edge. Is half the one at the center by the same chord. Is half the one at the center by the same chord or arc. Now we have angle AED. So this angle over here is half of AOD, which is half of 114. So half of 114 will be equal to 57 degrees. 57 degrees. So that's 57 degrees. Now we are calculating angle AED. You know this is a tangent, so this over here, this angle over here will be 90 degrees, and this one too will be 90 degrees. So the angle the tangent creates with the radii are 90 degrees each. And we know this is 114. We don't know this, so we are calculating it. So angle AED plus angle 114 plus angle 114 degrees plus the 290 degrees, which is 180 degrees. So let me go step by step. Plus 90 degrees plus 90 degrees will be equal to 360 degrees. So sum of angles in a quadrilateral. Sum of angles in a quadrilateral. Sum of angles in a quadrilateral will add up to 360. In a quadrilateral, is 360. It's 360 degrees. Now we can solve for angle AED. So we have angle AED to be equal to 180 minus 114. 180 minus 114. So 180 minus 114, then that will give me 66 degrees. So this minus this will give me 66 degrees. 66 degrees. So this angle over here is 66 degrees. Now we have angle OAC. Calculating angle OAC. So angle OAC from triangle OAD, from triangle OAD, from triangle OAD, we know that, let me call this angle over here X, this whole angle over here, we call it X, then this one too is equal to X. Now we know that X plus 114, so 2x plus 114 will be equal to 180 degrees. So we have angles, interior angles of a triangle add up to 180 of a triangle. Interior angles of a triangle add up to 180 degrees. Now we can solve for x, so we are going to get 2x is equal to 180 minus 114. So they are in degrees. So we have 2x is equal to 66. So this tells us that x is equal to 33 degrees. Now this will help us to calculate angle OAD. So this whole angle is 33 degrees. Now we know this whole angle is 33 degrees. Now we can calculate for this angle over here, angle CAD. Angle CAD. So we know angle CAD, angle CAD plus x, angle CAD plus x. So from triangle CAD, angle CAD plus this whole angle over here. So we know this is 33, this is 18. So this angle over here will be 90 minus 18. 90 minus 18. So this angle over here will be 90 minus 18, and this will be equal to 72 degrees. So the angle the tangent make with the radii. So the angle the tangent make with the radius is 90. So this small angle over here will be 72 degrees. So we need to calculate angle CAD, so that we can take it from 33 to get angle OAC. So we have CAD plus X plus, we have CAD plus X plus 72 degrees. So angle CAD plus X plus 72 degrees, then plus this angle over here, which is 57. So plus 57 degrees plus 57 degrees is equal to 180 degrees. So the interior angles of a triangle add up to 180 degrees. So angle CAD now, angle CAD plus, no, X is 33, so 33 plus 72 will give us 105. So plus 105 degrees plus 57 is equal to 180. Now if that is the case, then we can solve for CAD. So angle CAD is equal to 180 minus, into bracket, 105 plus 57. And this will be equal to 18 degrees. So angle OAC, what we are asked to calculate, angle OAC over here, angle OAC will be equal to 33 minus 18 degrees. 33 minus 18 degrees, and this will be equal to 15 degrees. Now we are asked to calculate angle ABC also. So angle ABC. So for angle ABC, we use the properties of a cyclic quadrilateral. We know this whole angle over here is 105 degrees. So angle ABC plus 105 degrees, angle ABC plus 105 degrees is equal to 180. So we have opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. So we can solve for ABC, angle ABC now to be equal to 180 minus 105 degrees, and that will be equal to 75 degrees. Now the B says that the diagram below shows a cuboid. So consider it has dimensions 60 by 20 by 100. Then we have the question I. It says we should give our answer correct to 1 decimal place. A straight adjustable wire connects R to P. So like this. Along the top of the cuboid, like this one. Calculate is from R to P. So calculate the length of the wire RP. So RP over here. Now this is the diagonal of the top rectangle or the top face. So we know this is 100, this is 100, and this is 60. So 100 by 60 over there, like that. Therefore RP, we can use the Pythagoras Theorem. The angle over here is 90 degrees. This angle over here is 90. It's a right angle. So by Pythagoras Theorem, you are going to get RP squared is equal to this side, which is RS squared, so 100 squared plus this side, which is 60 squared, or this side, which is 60 squared, so this will be equal to 10,000 plus 3,600 plus 3,600. So this will be equal to 13,600. Now RP will now be equal to the square root, the positive square root of 13,600. 13,600. And this will be equal to 116.62. So correct to 2 decimal places. Correct to 1 decimal place, you are going to get 116.6 centimeters. Now they said the connection at P is now adjusted and moved to T. So from P it moves to T, like this. So now we are supposed to calculate the length of RT. So RT over here. Now we use the same procedure to find RT. Now note that we have this triangle B form, triangle RTV. Triangle RTV. Now this angle over here is 90 degrees. So we can use the trig ratios again to calculate, or we can use Pythagoras Theorem again to calculate the length of RT. So this is 20 now, 20 centimeters now, by the down, the one that we just calculated, which is 116.62. So we have RT squared to be equal to 20 squared plus 20 squared plus 116.62 squared. So this will be equal to 400 plus 13,600. So RT, and if we add this, we are going to get 14,000. So RT now, the length of RT now will be equal to square root of 14,000 and this will be equal to 118.32. So to 2 decimal places, we are going to get 118.3 centimeters. So now we are supposed to calculate the angle TRV. So angle TRV, this angle that the diagonal over here, or this line RT makes with this side. So angle TRV. Angle TRV, we can use any of the trig ratios. So let's use the tangent ratio now. So the tangent of angle TRV will be equal to opposite over opposite, which is 116.62 over 20. So this will be equal to 5.831. So the tan angle TRV is equal to the tan inverse of 5.831, and this will be equal to 80.27. So to one decimal place, it will give us 80.3 degrees. 80.3 degrees. Now, they said compare the following statement. The size of the angle through which the wire moves from RP to RT. So the wire moves through this angle over here. So that angle over here is what we are looking for. So to find that angle, we just subtract 90, well, the whole angle over here is 90. So that angle is 90 minus 90 minus 80.27, and that will be equal to 9.73, which is equal to 9.7 degrees to one decimal place. An angle which is the same in size as RTV is, so angle which is the same in size as angle RTV is this angle that we just calculated, is angle PRT. They are alternate angles. So angle PRT is the same in size. So angle PRT. So don't forget to subscribe if you want to get a solution to the others. If you want to view the solution to all the questions, subscribe now so that if I upload, you get notified.